Hello, my name is Poeschko. I work for Wolfram Research on the cloud project, and I will talk about the cloud notebook interface, the progress we've made in the last year, and give some examples of what you can do with it. Hello, my name is Poeschko. I work on the Wolfram Cloud project. We're leading the development of the cloud notebook interface, mostly. And that's what I want to talk about today. I will give a brief introduction into cloud notebooks, try to explain some of the difficulties of trying to render notebooks in web browsers and show some of the technology we use in the background, and then highlight some of the things that we've achieved over the past year and show some things you can do now that you probably couldn't do a year ago with cloud notebooks. Probably all of you know the desktop interface of Mathematica, where you edit your documents, you enter expressions, you do your computations in a really nice notebook interface, and you probably also share notebook files with other people. And all of this nice experience, that's what we want to bring to the web. That's our mission. So the idea is that you can use notebooks as you know them from Mathematica in a web browser without installing a local installation of Mathematica, without installing a plugin. Just go to a URL, open the website, and it's a fully featured notebook interface where you can interact with your content. And to make this a bit more exciting, I'm actually using a cloud notebook right now. So what you see here is not desktop Mathematica, but it's actually a web browser running a local installation of the cloud. And so this is what I would call a cloud notebook in slideshow mode, as you know it from desktop Mathematica. So let me start with a few basic things. Maybe I should increase this a little. So as I said, this is a cloud notebook running in a web browser. But as usual, I can type some text here. I can have section cells, edit that. I can do evaluations, of course. So if I create a new input cell, 1 + 2, and press Shift-Enter, I get a result as usual. We also have this nice predictive interface here, so I can click here and go on. We also have some code assist features. So as you type, you can see some auto completions here. I can select a function, select a template for a function call, and things like that. We also have pretty nice support for graphics in cloud notebooks. So if I evaluate this plot, I get this thing, of course. I can resize graphics. So by dragging this around and letting it go, I have a bigger graphic now. What's also pretty cool is, I think, 3D graphics. Again, this is all purely running in a web browser. But still, I'm able to have a 3D plot like this and use my mouse and rotate this. What we've added rather recently is that I can also select this and resize this as usual. So I think that's pretty cool. We also are continuously improving support for typesetting. So if you have a rather complex result like this, it still looks pretty nice in the web browser. There are some things we have to improve here. The parentheses are probably a little too big, but otherwise, it's pretty nicely typeset math. Again, all in the web browser. What's also pretty cool is support for dynamics in notebooks. I think we've made some good progress there. So in its most basic form, what we support is dynamic of some variable. And as usual, that just displays as the variable itself until it gets a value. As soon as I change the value of var, let's say 2, you can see that the output up there immediately updated as soon as I change this variable here. I can also construct whole user interfaces on top of this. So if I have a button with a certain caption, it can increment that variable, and now when I click it, you see that the value up there changes dynamically. We've also just rather recently added support for dynamic option values. So you can have something like this, where you have a piece of text where the font color comes dynamically from a certain variable. Now, as soon as I assign something, let's say I want this to be red, the text changes its color. Maybe even cooler is if I connect that to a color setter with a dynamic setting, then you can see it's immediately red, but I can click this, select a different color, press OK, and again, the text up there changes. So that's sort of a way to build complex user interfaces in Mathematica, in regular Wolfram language, which still work in a web browser. It's sort of our way of doing two-way data binding in web applications. Now, if you have tried web programming before, you can already appreciate probably this is not an easy thing to do, but for everybody else, I just want to quickly demonstrate what's hard about this problem. And there are basically two kinds of challenges. The one is that we have to make sure that typesetting in general works correctly. That's what you really expect when you work in a cloud notebook or in a notebook in general, of course. You want your math or any output to look nicely, of course. And some of the challenges there are custom line breaking that Mathematica does in a pretty nice way, but also things like baseline alignment and things like that. So we have to make sure that works properly. But then in addition, there are also sorts of dynamic interactive elements that you can easily construct in the Wolfram language that we have to support in cloud notebooks. So if you take something like this, like a grid with a pretty large number, and it also has a second column with another number, what you would expect and what you actually get in a cloud notebook is that it line wraps nicely. You know, you don't get horizontal scrolling. The number line wraps here. You get sort of 3-digit groups to make the number more readable, and this is aligned here and so on. It looks pretty nice, and you have all right to expect it, of course. But if you think about plain HTML, I mean, it's easy to generate that. You can have a table in HTML with some cells, and Mathematica will actually generate this for you if you say export string to HTML fragment. But when you then look at this, and I'll just use a simple cloud object with this HTML code to demonstrate this. So if you go there, now what the browser does is not looking very nice. I mean, this is just a table with this single very long line, and then this is not aligned very nicely. I mean, maybe we could work around this in this particular case, but that's just to illustrate that the browser by itself would not do at all what we want here. And when it gets more sophisticated, or I mean, not even too sophisticated, but you have something like a fraction here, all that's really possible in the end is to generate an image. So in this case, if you ask for the HTML fragment, it will actually produce an inline HTML image. But yeah, that's not really what we want, and the reason is that the output should still stay interactive. We still want buttons to work, tooltips to work, so using plain images is not really an option for us. And so yeah, that basically means that we have to take care of all the typesetting, of all the layout of output and also input in notebooks ourselves. We can't rely on the browser. We have to implement basically a layout engine in JavaScript from a very low level on. And what this means in turn is that we have to implement the box language of Mathematica. Some of you might be familiar with this, but just to illustrate, whenever you have some output in Mathematica, like this simple formula here, what's going on in the background is actually a symbolic representation of this visual thing. And you can see this by applying two boxes. So what Mathematica does in the background is it turns this into a row box of a fraction box, and then there's a superscript box. You can also look at the tree form of this. So it's sort of a nested structure that represents this, this visual output up there. And that's, of course, a very general theme in Mathematica, that everything can be represented as an expression, which is really nice. And that also applies to visual output. And there's over 100 different boxes overall. There's some related to graphics, both 2D and 3D. Then there's some boxes related to traditional mathematical typesetting, and then there's many boxes for dynamic controls like buttons and so on. And so one of the major challenges and tasks that we have to do is implement these boxes basically in JavaScript so that they work in a web browser. And the way we've addressed this has sort of evolved over time. So in the beginning of the project, the very lowest baseline was basically to produce image-based output. That's how things started. Things looked fairly okay, but they were not interactive at all. And for the editor, I guess the baseline is a very simple plain text editor, basically just using a text area as the browser would provide anyway. But then over time, one thing we realized that one thing that's very important is, of course, manipulate. So we added a custom JavaScript-based implementation for manipulate, which meant that when you evaluate and manipulate, we would intercept that at a very high level and replace whatever it would do otherwise with some very custom JavaScript widget that supported things like simple sliders and image-based output within. But there was no chance this would evolve into a fully featured manipulate as you know it from desktop Mathematica with all the options regarding layout and control positioning and these things. We did the same for 3D graphics and 2D graphics, which meant that if you had the graphics at the top level of a cell, it would be sort of interactive, but as soon as you nested things, they didn't work as nicely anymore. For the editor, we gradually added some nice syntax highlighting, some auto completions, and so on. And that's basically where we were at last year, I think. And what happened within the past year is that we switched to a very fundamental, low-level implementation of most of the boxes in JavaScript. So that's what I was mentioning earlier, that we really have to take care of all this typesetting now in JavaScript. And we're also making use of that same technology in the editor. So when you have a large number and you want to edit it, it still stays in that nice mode where you have nice line wrapping here, and as you edit it, it doesn't overflow the notebook. And that's a consequence of using the same kind of rendering pipeline for both output and input. So that's where we are right now, basically. What's ahead of us is basically extending support for more boxes. I think we have a very solid framework now, and it's just a matter of implementing a few more boxes and all their options. And eventually, where we want to get at is an actual box-based editor. So right now, it's still kind of one-dimensional text that you can edit, but eventually we definitely want to get at something more two-dimensional where you can edit grids, superscripts, and all sorts of mathematical constructs, of course. So that's kind of the outline of the evolution of this interface. What this means now is that when you evaluate something or you interact with the browser page, the JavaScript client, it basically makes requests to the cloud where there's a Java server that basically just passes on expressions to a Wolfram engine running also in the cloud, or the kernel as you might call it, which, at least if it produces output, will respond with a box expression as we've seen it. So for instance, row box of fraction box of something. That goes back to the Java layer, which then makes sure that this is saved into the notebook and so on. But then it basically just passes on expressions to the JavaScript client. We encode it in JSON, but it's still very much just a raw box expression. And then the JavaScript client takes care of taking this expression and rendering it on screen. That's sort of the loop, how this works. Just a few words about what's going on in the background in the JavaScript layer. So we use something that's very natural use in such a case is model, view, and sometimes controller model or architecture. For the model, we basically have this tree from the notebook down to individual cells and boxes where we use JavaScript libraries like backbone and underscore to deal with that. So something interesting is how we deal with options, like we saw font color and font size, all these things. There are options that have to be passed down through this tree to individual boxes, where at each layer some things might change, but probably not too many of them will change, and there it actually makes sense to use immutable persisted data structures, which work pretty nicely in JavaScript as well. So yeah, that's about the model. And when it comes to rendering things on screen, that's where the view comes in, and there the task is basically to render the model into a collection of DOM nodes, which is the representation of content that the browser understands. And in each step, we have to keep track of dimension information, which is the width, the height, and the baseline of everything, so that we can lay out things on screen. What we do is actually we're using a library called React in JavaScript, which abstracts this a little bit. So we're never, or at least very rarely, interacting with the browser directly, modifying the DOM, but instead we build up a virtual representation of the content as you see it in the browser, and then this library makes sure that the browser is updated in the most efficient way, because usually the DOM is really the bottleneck in browser interactions. That's, yeah, I think a very nice library, just in case you're interested. Okay, so that's about some of the things we do in terms of the JavaScript client. Now, just want to show some of the things that work, that have never worked before in cloud notebooks. And one very important use case is, of course, manipulates. So if you have a rather complex manipulate like this here, it will work now, and you can see it has a rather, at least a rather custom control layout on the left-hand side. You have some nested objects in this area, and as you drag a slider, you can see that both sides update. What's also cool is that these graphics are interactive now, so I can resize this as usual. I can also go here and resize this. So these are the sorts of things that are possible now because of the arbitrary nesting of boxes, basically, and the full understanding of boxes in JavaScript. It also works for 3D graphics, of course. So if you have a manipulate with a 3D plot, you can both drag the slider and also drag this 3D graphics here, of course. So yeah, that's just a couple of examples about manipulate. We also, in general, increased support for dynamic module, and event handler, for instance. And I want to give a quick example of what's possible now. So the idea is to make graphics zoomable. I think that's a pretty nice feature on its own, but what's even nicer is that you can implement this now in top-level Wolfram language code. Without touching the JavaScript client, of course. And what this does is I have a plot, just the random graphics, and I wrap this in this zoomable function. I get a plot as usual, but what I can do now is I can click and drag up a rectangle, and when I let go, it zooms into this area. I mean, I could make this more sophisticated, maybe add a button to go back, reset the plot range, and things like that. And as I said, the nice thing is that this is all coded in top-level code. So what it basically does is you have a dynamic module that keeps track of the corners of the rectangle that you draw, and then that is used inside a dynamic construct inside the graphics. Also, we make use of dynamic option values, so that the plot range is basically a dynamic value. And when you click and drag the mouse, it's using an event handler to modify these variables. What's going on in the background is pretty cool, actually, because the only way to make this work reasonably well without lagging too much is by using a client-side evaluator. So there are some expressions, like, you know, this first variable is assigned the mouse position, and there could be a more complex expression here, of course, but at least for some sorts of expressions, we're able to not go back to the kernel to evaluate them, but we stay on the client side in JavaScript and evaluate it right away. Which means that you can basically construct pretty dynamic, interactive user interfaces in top-level code that still run purely in JavaScript in the web browser. Of course, this is still in a rather early stage, so not everything works in terms of event handler, for instance, but we definitely have a great path forward there. All right, so let's say you have some nice content that you want to share with others. What do you do now? How do you deploy that to the cloud? It's actually pretty easy. So if you have something like this manipulate, all you have to call is cloud deploy of this thing. It will give you a cloud object. Again, this is running on my local version of the cloud, but otherwise you just get a Wolfram Cloud URL. You go there and you have the interactive manipulate in a sort of minimal notebook interface. Cloud deploy actually tries to be a bit clever. So if you have something like a rather static expression, it will not produce an interactive notebook, but it will actually just rasterize the output and produce something that looks like a notebook. I think that makes sense in many cases where you just care about the visual representation. If you do want to make the distinction, you might want to use cloud export. That's very similar to what we did above, just cloud exporting the content and then say that you want a cloud CDF. And that will make sure that it always becomes an interactive notebook. So if I visit this object, I get, you know, a notebook. Right. Something else to keep in mind when dealing with cloud objects and deploying things to the cloud are permissions. So what you've seen here, these cloud objects, they're actually private by default. And the reason I can still see them is because I'm logged in, obviously. But I mean, first of all, you couldn't even go to my local host anyway. But if you could still not see them because they're still private to me. If you want to make things public, you have to use permissions. And that's an option to things like cloud deploy, cloud export, and similar functions. And the handy shortcut is permissions goes to public, which in the context of notebooks means that it's interactive for any user. So we can see at the sort of full form of these permissions options, it says now that everybody, even unauthenticated users, have read and interact permissions. That's something to keep in mind. There's pretty detailed documentation about permissions, which you might want to read. Now, you might wonder, with all that fancy JavaScript going on, isn't that becoming slow at some point? Doesn't it take a long time to just download all the JavaScript to the client, render things in a JavaScript evaluation until you see anything on screen? And that's actually true, and that we were concerned about that as well. So now a way we address that is that we cache a raw version of the notebook, an HTML-based version of the notebook, when you edit and close the notebook. So, as you close the notebook, we store a pure HTML-based representation of at least the upper part, the part that's usually visible of a notebook on the server side. And then when you next open the notebook, could be you or anybody else, that's the thing that we send down to the client initially. So what the browser immediately sees is this raw HTML version that it can immediately render, and it's very fast with that. While in the background, we download all the necessary JavaScript code, all the necessary resources, and so on. Just want to give a quick demo of that. If we cloud deploy this manipulate, I put a little delay in there. Just evaluate something, but we also pause for 3 seconds for this to be for this effect to be more visible. So now when we first go to this object, we see it takes a little while to generate this manipulate. And usually that might even be a little longer because I'm running my local machine now, so there's not much of a network overhead. But you might imagine that on the internet, there's more overhead in downloading all the JavaScript and additional resources. But here, for the demo's purpose, I just added this artificial delay. So you saw this little delay, and there was this little dot animation spinning. But now let's close this one and open it again. And now this just comes in immediately, as you might have seen. And also notice that there was no real transition. That's what we worked on pretty hard to make sure that you don't really notice the transition from the cached version, that's just raw HTML, to the live JavaScript-based rendering of the notebook content. So now I can still, it takes a while because of this artificial 3-second pause, but of course this is interactive as usual. Right, that's the idea with HTML caching. We've also made some mobile-specific improvements. That's also a very relevant, interesting area, of course. You want to be able to not only view notebooks in traditional web browsers on desktop computers, but you also want to deliver them to mobile devices. And so what we did is we worked on a mobile application, at least for iOS for now. An app for Android is coming up as well, where we basically wrap the cloud notebook technology in a nice app that allows you to browse through your cloud files and view shared files and so on. And then you can open notebooks and other cloud objects, and you get an optimized experience in terms of interacting with the notebook. So for instance, we provide a custom keyboard that makes sense for Wolfram language, and selections of cells and moving the selection around, that works slightly differently on mobile devices. That's the story there. Oh, wait. Another thing I want to briefly mention is embedding notebooks. I think that's quite relevant. So you might have some, content, some manipulate that works really nicely in its notebook form, but then you might still have your general website, your company website, and you probably don't want to switch everything over to a notebook interface. I mean, in an ideal world, maybe everything would be a notebook, but it's totally understandable that there is still HTML out there. There's lots of HTML. So we want these. We don't want to create an island that and not be able to interact with other things. So what you can absolutely do is, of course, embed notebooks in an iframe. And actually there's a function called embed code that should give you that little piece of HTML you need to embed a notebook in an HTML page. But then I think what's also really interesting is to be able to interact with that notebook from the outside world, basically. So you might want to be able to, create cells from JavaScript, using some JavaScript code, create cells in the notebook you embedded, or do all sorts of things. And we're just creating an API that allows you to interact with notebooks from other JavaScript code. I'm going to give a quick demo of that. I basically created a small HTML page. I actually created this in the cloud. So that's the cloud interface as you would usually see it. And you can not only create notebooks here, but as you might know, you can also create HTML pages, for instance. And so this is the HTML editor where you can see an iframe here that's just referencing another notebook I've created before. And then there is some JavaScript code. Let me first show you what it does. So it looks like this. Oh, should have actually deleted this. I don't have to delete this. The idea is that you have this regular HTML page and then this embedded notebook. You can see it's still a regular notebook where I can type in, of course, but now I can also use these buttons here to interact with the notebook. So this one is asking me for an expression to insert, and then it will create a corresponding input cell and immediately evaluate it. I have already created this dynamic plot here. There's a little bug with the plot labels. Maybe you can ignore that. So you can still create cells here. Now I can also evaluate arbitrary expressions and basically send them into the notebook, which will forward them to the kernel if necessary. So if I now enter a new value in this JavaScript interface, it will go to the notebook and update this plot immediately. And the way this is done in the code is quite straightforward. Basically, we have this notebook interface class in JavaScript that has functions like insert cell at cursor, evaluate a cell, evaluate expression, and so on. And one particularly nice thing that we can do with this is, for instance, animate things. So by pressing this button, JavaScript will go ahead and just use an interval and update the variable t continuously, and you can see that the notebook updates accordingly. So in the code, it's as simple as this here, basically. Yeah. So stop this. Of course, you should also be able to do all of these things in the Wolfram language, and we're definitely working on let's say animator box and things like that. But it might still be nice to be able to control things from JavaScript if you want to. There's, as I said, we just started working on this. There's quite a few API methods already, but it's not completely stable and documented yet. But I definitely like to know if you have some use cases for this, maybe that can inform how we design and document this API. And that's pretty much what I wanted to say about cloud notebooks. Just to give a quick summary, I've tried to explain some of the reasons why notebook rendering in browsers is hard, shown you what progress we've made, what you can do now. Some of the things we're very actively working on is still extending support for boxes in the web browser, while also improving performance of notebook rendering and also the editor in particular. We also keep adding input assist features, like more intelligent auto-completions. And then something really important, I think, is extending documentation of things that work and that don't work in the cloud. So far, we haven't done that too much because things have been changing quite a bit, and it didn't make sense to say something didn't work when a month later it would work anyway. But I think now things are converging more and will definitely be better with documenting these things. Then more future directions for cloud notebooks are certainly the two-dimensional box-based editor I've already mentioned earlier. And something we also really want to get at is live collaboration on cloud notebooks, meaning that 2 or more users can work on the same notebook at the same time and seeing each other's changes. That would really be nice. Would be really nice, I think. Right, that's all I wanted to say. Thank you very much for your attention.